Hi everyone, my name's Alyssa and this is my Module 2 Zoom report. So today we're going to start with number 1 and we're going to take a look at that. And it says let U equal set A, B, C, D, E, F, G, H and A set be B, C, D, G, H with B set being D, F, H and C set being D, G, H. We are to create a 3-loop Venn diagram to show all 8 elements of U and then list the elements in the following sets. So down here I have drawn a box, which that's U because U contains every single set. So then I have my Venn diagram of A, B, and C with all of the sets within each respective circle. So down here we are supposed to find the following elements in the sets, okay? So we'll start with A. And we have B, and then we have this thing that looks like a U, but actually that is called a cup. So to me, the easiest way to list that is that means all. What is everything within B and C? So that would be D, F, H, and G. And then we have A and B, same thing. So what does A and B have? B, C, D, G, H, and F. Okay, so then we have B and the upside down U looking thing and C. So that's a cap. So that means both. What do both B and C share? They both share D and H. Okay, so then we have A and C, which that is again the all is like what I like to call it. And that is B, C, D, G, and H. So then we look at E and we see A with this line above it. What does that mean? That means the complement of A. So basically what that means is what does A not contain? Which A doesn't contain A, E, and F. A and E are outside here because U is the only thing that contains that, and B is the only one that contains F. So then for F we have A and then the cap C. So that is D, G, and H. And then we have A with the cut, parentheses, B and C. So that answer is B, C, D, G, and H. So for those problems, all you do is make the Venn diagram and then refer to it to find the sets. So for number 2, we have this cool little thing. And it says the 12 shapes in the Venn diagram shown are described by the attributes of shape, size, and color. Let C, H, and T denote the sets of circular, hexagonal, and triangular shapes respectively. Let S, L, R, and B denotate the sets of small, large, red, and blue shapes respectively. So the set of A contains the shapes that are small and not a triangle. So here's A set. And so A equals S, and then we have the cap, and then the complement of T. So then we are to complete the questions A through D. So here it says describe which shapes are found with L and H. So that would be large hexagonal shapes, which L is the large and H is hexagonal. So for B, describe which shapes are found with C, and then we have the U looking shape again, H. So that would be all circular and hexagonal shapes. Then for C, describe which shapes are found with T, and then we have that cap again with the complement of R. So that would be triangles that are not red. And then for D, we have describe which shapes are found in the set CSR. So that would be small circular red shapes. So for number 3, these are some of my favorite problems. So you are to write the Indo-Arabic equivalent of each of the following. Show all keys used for the translation. So down here, I've kind of written a key. So we have the pointing finger, the yoke, and the staff. A pointing finger equals 10,000, a yoke equals 10, and a staff equals 1. So we have 3 pointing fingers, 5 yokes, and 4 staffs. So that comes out to be 30,054. So down on B, we have MCM XXXVII. M equals 1,000, C equals 100, X equals 10, V equals 5, and I equals the 1. So there we have M, so that's 1,000, CM. So with the C coming before the M, you're going to subtract 100, which is what C is for, from the M. So that's 900. So then we have XXX would be 30, 1V is 5, and then we have 2 of the I's, so that would be 2. So altogether that should be 1,937. For C, we have these arrows and then the spike. So for the arrow, that equals 10, and the spike would be 1. So 4 arrows is 40, 1 spike is 1. So altogether, it is 41. Now, this is one of my favorites. So right here, this line right here will equal 5. So down here, we have a line and a dot. So the line we already know is 5. 1 dot is 1. So that would be 6. 3 dots is 3. And then we have 3 lines, which would be 5, 10, 15, 16, 17 with those 2 dots on top. So altogether, I have my math right there, that would equal 31. Okay, so for 4, we're going to use lattice multiplication for parts A through D. So for A, we have to multiply 28 by 32 using the lattice algorithm. So here I've drawn a set of boxes, and then within the boxes, it looks like triangles. This kind of looks like the way you'd cut a sandwich almost. So we have 28 written right here, multiplied by 32. So what you're going to do is you're going to write all of your boxes, and then you're going to divide each box. So all these are going to be connected, kind of like lines. I've drawn arrows to show your divided lines. So then you're going to solve. We'll start here. 8 times 3 is 24. 8 times 3 is 24, and then 2 times 3 is 6. 8 times 2 is 16, and then 2 times 2 is 4. So whenever it's just a single digit answer, you're going to put a 0 in front of it. 0, 6, 0, 4, 0, 1, 0, 2, whatever you're dealing with. So I have all my math right there. And then the cool thing is you are going to add to find the answer. So this is all by itself. So 6, 4 plus 1 plus 4 is 9. 0 plus 6 plus 2 is 8. And 0 is obviously 0. So 28 times 32 is 896. You can check your math by using a calculator, but that is correct. So for B, same deal. Multiplying 273 by 628 using the lattice algorithm. So 273 written there, 628 written here. So then you're going to have all of your answers. You're going to multiply 3 and 8, 7 and 8, 2 and 8, and so on and so forth to come out with 171,444. Now for this next one, I've gone more in depth about carrying over with the lattice algorithm. I've written that in red. So you're going to multiply 964 by 593 using the lattice algorithm. So 964, 593. 4 and 5 is 20. And then you're going to have 6 and 5, 30. 9 and 5, 45. 4 and 9, 36. 6 and 9 is 54. 9 times 9 is 81. Then 9 and 3 is 27. 6 and 3 is 18. 4 and 3 is 12. So then we're going to do our addition. 2 is 2. 6 plus 8 plus 1 is 15. So where do I carry that over? Well, you're going to carry it over here, that 1. So you write your 5 here and your 1 over here. So I've written that in red. 1, 7, 1, 4, 3. All of that comes out to be 16. Again, carrying over. 2 plus 1 plus 1 plus 5 plus 2. That gives you 11. And then so on and so forth until you have your answer, which is 571,652. So then you're going to multiply 4,952 by 243 using the lattice algorithm. You're going to again write your little squares and do your multiplication, all to come out with 1,203,336. You see that we had to carry over 2 instead of a 1 here, but the same rule applies. So then we're going to have question number 5. Using rounding to the leftmost digit to estimate the results of each of the following expressions, and then make the exact computation. Discuss your results. So first we start with 883 plus 465 over 134. The estimation, so 883 rounded is going to be 900 because anything 5 and above is going to round up. So that would be 900. 465 would be 500 because the 6, again, big, so go back up. And then 134 would round down to 100 because 3 is obviously less than 5. So you come out with 1,400 divided by 100 is 14. Now the real world computation, as we figure, turns out to be 10.059. Now there's about a difference of 4, so the estimation gave us a bit of a larger answer. Some estimations will give you larger, some will give you smaller, and we'll just keep looking at those. So then we have 5 times 254 plus 523. That would round to 10 times 300 plus 500 over 40 plus 10. So then you're going to do your multiplication first, which would be 3,000 then plus 500, 3,500. 40 plus 10 is 50, and that gives you 70. Now, when you do the real-world computation, you're going to come out with 42.69. So there's about a difference of 28. So the estimation kind of gave you a larger answer right there. And in C, you have 620 times 430 over 293. That's going to round to 600 times 400 over 300, and that's going to equal 240,000 divided by 300 gives you 800. Now, when you do the real-world computation, you're going to have 909.898, which, of course, that would round up to probably about 910. So that would give you, and the estimate was less that time instead of more. Okay, so then we have number 6. Now, these used to be tricky until I like to visualize what I'm doing. So I used a dot representation. So we're going to do 432 in the base of 5 plus 133 in the base of 5. So what we're doing is we're performing the following operations with the relative base. So bases of 5. We'll have 1s, 5s, and 25. 1 times 5 is 5. 5 times 5 is 25. So we have 432 and 103 represented. So 4, 3, and 2 dots, 1, 3, and 3 dots. So you're going to group together these dots. 5 dots would be one of these dots. 5 of these dots would be one of these dots. And you're going to come out with 1,120 with the base of 5. B, same thing, only base of 6. So you're going to set up your table. 1 times 6 is 6. 6 times 6 is 36. Now, instead of using 5 dots to represent the following dot, to represent one of these, it would be 6 dots. So you're going to carry those over each table. So you have more than 6 dots here, you're going to carry 6 over to this column. More than 6 dots here, carry over to this column, and you end up with 1,145 in the base of 6. So here we have subtraction. This is a little bit trickier, so I used red to kind of show you where we're going with this. So you're going to make your same table for the base of 5, represent your numbers the same, but instead this time you're going to take the dots and subtract. So 4 minus 3 is 1. You cannot take 1s and subtract 4, so you're going to borrow one of these dots, which equals 5 dots. Draw those here, and then you're going to have 6 minus 4 is 2, and then those 3 dots just gives you 321 in the base of 5. Down here, same thing, 503, 5 minus 24, 5. So you have 25, 5, and 1 again. So you're going to represent 503, 5 dots here, no dots here, 3 dots here. 24 is 2 dots here and 4 dots here. You're going to have to borrow a couple of times to get this answer because you cannot subtract 3 minus 4. So borrowing a dot here gives you 5 dots here. Then borrowing one of those dots will give you 5 dots here. So you're going to end up with 5, 6, 7, 8. 8 subtract by 4 is 4. And then 4 dots here, subtract by 2 is 2. And then 4 dots remaining is 4 here. So you have 424 in the base of 5. So that completes Module 2 written exam. I hope you've learned a little bit more about it. And come back and watch us next week.